Hello, grade 8. Our math lesson today is about the circle. The blue curve represents a circle C of center O and of radius R. The curve is made of points whose distance to O equals the constant R. A, B, and C are points on C. OA equals OB equals OC equals R. K is a point inside C. Therefore, OK is less than R. L is a point outside C. That's why OL is greater than R. O is the center of symmetry of C. A segment from the center O to a point on C is called a radius. OC, OB, and OA are radii of this circle. A segment having 2 points as extremities on C is called a chord. BC is a chord since B and C are on C. AB is also a chord since A and B are on C. A chord that passes through the center is called a diameter. AC is a diameter since A and C are on C and the segment AC passes through the center O. The diameter of the circle is equal to 2 times the radius of the circle. Any diameter of C is an axis of symmetry of C. So, the measure of AC is equal to twice the measure of OC, or twice the measure of OA, or twice the measure of OB, and AC is the axis of symmetry of circle C. The circumference of C is equal to 2 times pi times r. Pi is equal to 3.14 and r being the radius. So to find the circumference of any circle, you need to multiply 2 by 3.14 by the radius of this circle. The colored part shows the disk of center I and of radius R. E, H, and N are points on D. IE equals IH equals IN equals R. IF is less than R since F is a point inside D, and IG is greater than R since G is a point outside D. I is the center of symmetry of D. A segment from the center I to a point on D is called the radius. Since E, I, and H are 3 collinear points on D with IE equals IH equals R, then segment EH is the diameter of D. In other words, since EH is a segment passing through I, the center of the disk, and E and H being on the disk D, then EH is the diameter of D. Diameter is equal to 2 times radius, and it is an axis of symmetry of D. The circumference of D is equal to 2 pi r, and here, to find the area of the disk D, we need to multiply pi, which is equal to 3.14, by the radius raised to the power of 2. Relative positions of a line and of a circle. C is a circle of center O and of radius R. Let D be the distance from O to line D. D is equal to OH. You must remember here that to find the distance from a point to a line, you must draw the perpendicular passing through that point to that line. That's why OH must be perpendicular to line D. In the first case, D is greater than R. Line D and circle C don't have any point in common. D is outside C. In the second case, D is less than R. D and C are secant. They intersect at A and B. D is a secant to C. In the third case, D is equal to OH, which is equal to R. D and C are tangent. They have one point in common, which is E. D is the tangent to C at E. What is a tangent? A tangent to a circle at a point is a line that is perpendicular to the radius at that point. This point is called point of tangency. As you can notice in the third figure, line D is perpendicular to OE, which is the radius, at point E. So, point E is called point of tangency. Circles passing through two given points. An infinite number of circles can pass through two given points A and B. Their centers are on the perpendicular bisector of segment AB. A and B are two given points. To draw some of the circles that pass through A and B, we first have to join A and B to obtain segment AB, and then to draw the perpendicular bisector of segment AB. Then we can take any point on that perpendicular bisector. This point is going to be the center of the circle passing through A and B. At first, I take point O, and I draw the circle of radius OA. This circle passes through A and B. Now I take point I. I draw the circle of radius IB and of center I. The circle passes through A and B. I take J and I draw the circle of radius JA and of center J. The circle passes through A and B. And at last I take point K. I draw the circle of center K and of radius KB. The circle passes through A and B. I can take an infinite number of points and draw an infinite number of circles that pass through A and B. Circle passing through three given points. If points A, B, and C are collinear, a circle doesn't pass through the 3 points. As you can see in this figure, A, B, and C belong to the same line. I can draw an infinite number of circles passing through A and B, an infinite number of circles that pass through B and C, and an infinite number of circles that pass through A and C. But I cannot draw a circle that passes by the 3 points at the same time. One circle passes through 3 given non-collinear points. Its center is the intersection of the perpendicular bisectors of the sides of the triangle formed by these 3 points. The center is called the circumcenter. The circle is called the circumcenter circle. A, B, and C are 3 non-collinear points. First, I need to join the points to form a triangle. To find the center of the circle that passes through A, B, and C, we must draw the perpendicular bisectors of segments AB, BC, and AC. The point of intersection of the perpendicular bisectors is the center of the circle passing through the 3 points. At last, draw the circle of center J and of radius JB. The circle passes through the 3 points A, B, and C. Arc of a circle. The part of C limited by A and B is called arc of a circle with extremities A and B. Therefore, A and B determine 2 arcs on the circle, a minor one and a major one. The smaller of these arcs is denoted by arc AB. The arc of a circle has a length. The circumference of the circle C is 2 pi r. So the length of AB is 2 pi r over 4, which is equal to pi r over 2. The length of BC is 2 pi r over 2, so it's equal to pi r. In a circle, any diameter perpendicular to a chord passes through the midpoint of this chord and of its arc. In this figure, the diameter is perpendicular to chord AB. As you can see, the diameter passes through the midpoint T of this chord, and it passes through the midpoint of the arc AB. That's it for now. Thank you for watching.